This is space. And no, I don't mean the part filled with stars and satellites. This image of the world is letting us see part of geographic space. The Earth is covered in features and relationships that we can measure and study in a variety of ways to better understand our environments. For example, if I were to zoom into your community, I might measure the space by counting the buildings to get a sense of how big it is. But this is your community, so you know where the place is to catch up with a neighbor, like an eclectic coffee shop or walking the sculpture park. I only see the physical buildings, while you understand the importance of each building. We're looking at the space in two different ways. But there are more ways to discuss space, and they each add a new layer of understanding. From measuring it, to defining it, to understanding the relationship between places. Just as all historians study events in time, based on what's going on or what's normal for a time period, all geographers study events in space. No matter the topic, we end up contextualizing places or human-environment interactions based on the space they exist in. I'm Alize Carrere, and this is Crash Course Geography. In geography, we ask questions to understand what is where, why it's there, and how it's changing. So when we're trying to interpret why glaciers melt or disease outbreaks happen in certain places, we want to both measure space, to get the lay of the land, if you will, and try to understand the significance space has to what's happening. As geographers, we can think about space in four broad categories that emphasize different aspects and use a suite of tools and techniques to help us with measuring and understanding our world. In its simplest form, we can think of space as a container, like a box or an extra large Tupperware container for delicious banana bread. We want to know where stuff is, basically what's inside or outside the container. The Earth is like a stage, and everything from cool rock formations to political protests happen on that stage. Studying space as a container helps us answer the question, what is where, by measuring and locating physical features or borders or boundaries. To do this, geographers and other people who work with distances and points, like surveyors, use a coordinate reference system, like overlaying a square grid on the globe. Even our phones can be used to tell us what is where. When we open Google Maps on our phones, the phone connects to a global positioning system, or GPS, which pinpoints the location of an object on the ground using radio from satellites. When a receiver on Earth, like our phones, receives a radio wave from 3 or more satellites, the phone can translate those signals into a precise location and know exactly where we are. These days, all the satellites launched by the US, China, Russia, the European Union, India, and Japan are called the Global Navigation Satellite System. While it's great to know where things are, as geographers we want to go beyond that. Even our phones tell us more than just where the sculpture park is. Once we know where things are in space, we can understand how they're related, or their spatial relationships. In fact, humans are hardwired to think about spatial relationships and how we're related to the space container around us. To describe those spatial relationships, we need to recognize topological space, which measures and analyzes how the features in space are arranged and connect to each other. This term comes from the word topology, which refers to how the pieces of something are related or arranged. We also see topological space in action every time we ask our phones to route us somewhere. We're really asking Google Maps to look at how our beginning and ending locations are related and find the most efficient connection based on what's physically in the area. Spatial analysis is a blend of geography and math that identifies and analyzes those patterns and relationships in space using a range of techniques, including imaging technology, statistics, and geometry. To see those spatial patterns and understand how space changes over time, sometimes it helps to zoom out and stand back. Remote sensing, or studying something without physically contacting it, is an entire subfield of geography that lets us do just that. Photogrammetrists and other remote sensing professionals compile and analyze images from satellites, airplanes, or drones that have sensors that record energy reflected from the Earth's surface. The reflected energy is sensed by a device that records the wavelength as a number and turns that number into a pixel in an image. Remote sensing has been particularly helpful in Antarctica, which is incredibly hard to study in person. Covered in ice and snow, this frigid continent has been one of the least mapped areas on Earth, and for good reason. Antarctica is considered the coldest place on Earth and the windiest. Conditions are so extreme that hiking around and recording the terrain in a ground-based mapping effort is nearly impossible. So in 1997, researchers collaborated with NASA and the Canadian Space Agency to use remote sensing satellites with radar capabilities known as RadarSat to scan the surface of Antarctica. They generated accurate images of the surface ice and snow on Antarctica by measuring the echo of radio waves sent from a radar satellite. With this data, we can start by defining the boundaries of features in Antarctica, like the location of large cracks in the ice called crevasses. We're defining the space, or container, that is this polar continent. But definitions of any kind are really just the initial building blocks. In Antarctica, we can use that information to analyze our relationship to those features. Crevasse zones are dangerous to cross and difficult to see from the ground, so knowing where they're located can help create safe travel routes. This can save time and lives when trying to navigate this dangerous terrain. But our spatial relationships are more than just routes. The radar dataset is also used to measure how quickly glaciers are moving, which gives us insight into the physics of glaciers and lets us better predict how glaciers change. We can build a more complex understanding of a space when we ask not just where is the crevasse, but how is it changing? Or where is that ice moving? Now, containers and topology are informative, but they don't let us talk about the more subjective things we know about a space. In geography, we can also talk about socially constructed spaces, or those spaces we create and give meaning to as communities, like that coffee shop or sculpture park. In fact, the socially constructed space doesn't even have to be physical. The way we develop and define virtual spaces, like the fan communities we form and participate in online, is a whole subfield of geography. But let's stay in the physical realm, in, for example, Harbin, China. Each January, blocks of ice from the Songhua River that flows through the city are carved into sparkling sculptures as a part of the annual Harbin International Ice and Snow Sculpture Festival. Originally, ice lanterns were mostly used at night on the river by fishermen. They gradually became an art form and eventually a major social and cultural event. Now, the wonder of the Ice and Snow Festival is synonymous with Harbin. By studying socially constructed spaces, we learn how space is carved out and a place or a location with meaning is created and can become sites for social, political, or economic activity. Individuals, not just communities, can also create meaning in space. We study individually perceived space to incorporate the idea of place and see how the perception of a space can change person to person or culture to culture. Like a teenage girl living in Harbin might hold a mental map of her neighborhood that includes points of interest to her, like the curb she almost twisted her ankle on while jogging. That's her perception of that space, just like we all have our own perceptions of our individual spaces. And we can see how the perception of individuals or groups has changed over time. Today, Harbin is the 8th largest city in China, but its name was originally a Manchu word meaning a place for drying fishing nets, which hints at how past inhabitants perceived and used the space. Any space can be studied through any of these 4 lenses: as a container, topologically, socially, or how we individually perceive it. Let's go to the thought bubble. In January 2010, a magnitude 7.0 earthquake shook the nations of Haiti and the Dominican Republic, creating massive damage and killing hundreds of thousands of people. But things could still get worse. Relief efforts in Haiti were delayed because aid workers didn't know where to go or how to get there. Clear maps of neighborhoods and remote regions of the island before the quake just didn't exist. So international aid workers had no sense of space and no fast way of learning. But the locals did know the area, what was there, how it was organized, and what it meant for their communities. So that collective knowledge, or perceived space, was put to work. In 2 weeks, Haiti went from no map to a complete map in the first crowdsourced mapping effort for humanitarian purposes. A team of mappers organized people around the world to help digitize photos, which means tracing images to create 2D shapes and attaching coordinates that can be plotted on a map. These humanitarians input aerial and satellite images into a mapping platform called OpenStreetMap. With OpenStreetMap, volunteers can look at space as a container and use those images to trace buildings, parks, roads, and more to create a basic digital map. That map can then be used by anyone in the world with access to OpenStreetMap. In Haiti, those maps meant relief workers could see where buildings should be and could use that to help identify where people might be trapped. Now they could find efficient routes to points they needed to get to and engage with the topology, or organization, of the space. The global effort to map Haiti was such a success because it brought together those who had technology to digitize the building boundaries and roads, and those who knew the significance of those boundaries and roads. With crowdsourcing, the sense of space could be complete. Thanks, Thought Bubble. Since 2010, communities around the world have worked within OpenStreetMap digitizing their buildings, roads, and other features. Local citizens imbue the map with meaning, like which of these buildings are houses, or where there are important community gathering places, hospitals, and businesses. Local groups and humanitarians can then create the maps they need to achieve their goals, from identifying areas at risk for disease spread, to identifying safe areas for persecuted groups, to helping locate people quickly after a natural disaster. Because anyone can update the map as spatial features change, the data is always fresh and ready to be used. Basically, anyone can be a geographer and create the maps their community needs. Space in all its forms is an integral part of our lives. We navigate space every day, rely on fresh geographic data to get from place to place, or give meaning to familiar and unfamiliar spaces without much thought. As geographers, we formalize that process. We take in spatial data from satellites, photos, radar, and personal observation and create data that allow us to locate buildings, route around traffic or physical features efficiently, and communicate the meaning communities give their spaces. We focus on space explicitly to better understand and explain the world around us. Many maps and borders represent modern geopolitical divisions that have often been decided without the consultation, permission, or recognition of the land's original inhabitants. Many geographical place names also don't reflect the indigenous or Aboriginal peoples' languages. So we at Crash Course want to acknowledge these people's traditional and ongoing relationship with that land and all the physical and human geographical elements of it. We encourage you to learn about the history of the place you call home through resources like nativelands.ca and by engaging with your local indigenous and Aboriginal nations through the websites and resources they provide.